Hi everyone. Today let's look at the LeetCode problem 1644. Lowest common ancestor of a binary tree 2. It's a slight variant of problem 236 in LeetCode. Given the root of a binary tree, return the lowest common ancestor of two given nodes P and Q. I would highly recommend you to look at first solve the LeetCode problem 236 before you do this problem. Okay, so all values of the nodes in the tree are unique. So like what this is basically you have to find the lowest common ancestor. So assume that you have 5 and 0, then 3 is your common ancestor, the lowest common ancestor you have. But if you take maybe like 2 and 6, then 5 is your lowest common ancestor. Even though 3 is an ancestor, this 5 will be the lowest common ancestor before 6 and 2 diverges to a different subtrees. Okay, the important part about this problem is that there is a possibility that P and Q might not also exist. So if they don't exist, then you have to return null because you couldn't find the nodes. Okay, so that's it for the background of the problem. Now as I mentioned earlier, do solve the problem 236 before trying this out, because the solution that we are talking is or the intuition that we are building is on top of the solution of problem 236. Okay, now let's take the different scenarios here, right? One is P and Q will be in different subtrees. Okay, the other case is P is a parent of Q. So in that case, your ancestor will be P, or Q is parent of P. Then P is not present in tree, Q is not present in tree, or we could have P and Q not present in tree. So let's dive into each of these scenarios, right? So the first case is P and Q in different subtree. So this is like a very basic thing. So here, as you can see here, 5 is in the left and 8 is in the right subtree. So this can apply to anything. For example, you could have a case where you're looking for 6 and 2. So here also they are in different subtrees. So what this refers to is neither P nor Q is its common ancestor. It's a different node. Okay, now the next case is where P is a parent of Q. Okay, so then that means 5 will be the ancestor node. Okay, the other case is the other way around. It could be like Q is a parent of P. So basically Q will be your ancestor. Now as you can see, I have a link to the video for the solution of problem 236. These 3 scenarios will be taken care in that solution. Okay. Now let's take the other cases now. Now this is a case where it is one of I should have put P here. Okay. So P is not there in the tree. Sorry, my bad. This is correct. Q is there, but P is not there. So how to tackle that? The other case is where P is there, but Q is not there. And finally, the last case is where neither P nor Q is there. So with the existing solution of 236, we will not be able to detect these 3 scenarios. Okay. Now, let's try to build an intuition here. Okay. Now let's take this case, right, with the current solution. So assume that you are looking for maybe like 2 nodes here, right? 5 and 0. Okay, I'll make it very simple here. So in this particular case, if you refer to the solution in 236, what will happen is you will come here. This will return 5. And of course, this will come here. It will come here. So you will get 0 here. This will end up returning. It will come here. This will return null. So what will happen is you will come here with 0, and so 3 will be returned. because that is your common ancestor. So this is applied for any case. So as you can see here, this is a very specific case where your ancestor is not P or Q. So if that is the case, then this will work. Okay, the existing LCA solution as it is will work. All right. Now the other case is P and Q is not in the tree. So if it is not in the tree, what will happen is it will go to all the nodes. This will return null. It will come here. This will go here. This will again return null. Same here. This also will return null. It goes back. This also is null. So now we return a null here. Okay, same applies in this path also. So what will happen is this is null. You come here, this also returns null. And of course, you will get a null here. Sorry if I'm writing. So at the end of the day, since both are null, 3 will also return null. Okay, so this is the basic intuition. So these two scenarios by default will be taken care. Now, the problem scenario is a case where, imagine that you have a case where only you have either P or Q is missing. So assume that we have one node which is already there and you have something like a 10 which is not there in this list. So then what will happen is, with the existing solution, it will come here. This will return 5. Okay. And it will come to this path as mentioned earlier. So you couldn't find the node. Okay. So I'm not rewriting here. So this also will go to null actually, because from here you didn't find the node. So this assumes that your answer is 5. So this is a case where this issue happens only in a case where this is mainly because the other solution assumes that you actually have the node in this area. Okay, so what we can do is we will actually look at this node. Okay, even if and we will check whether it is equal to P or Q. All right, this value is actually equal to P or Q. If this value is equal to P or Q, we will just do a DFS on its subtree. Okay, if this DFS returns the other Q or the P, then that means it's a valid lowest common ancestor. If not, we'll just return none. I hope the intuition is clear. Okay. So the first step is we will take tree node star. Just put ancestor is equal to LCA of root comma P comma Q. So now let's take the normal the helper function to find the lowest common ancestor, assuming that we have both the nodes available for searching, available in the tree basically. So this will be okay. If so, we'll go to the earlier solution as it is. This is the same solution as for 236. LeetCode 236. If root equal to null PTR or root equal to P or root equal to Q, then we'll return root. Otherwise we will do a L search. Is equal to LCA of root of left comma P, comma Q. And we will similarly do an R search. Okay, so this will be this way. And if L search not equal to null PTR and R search not equal to null PTR, this is the diverging node. Okay, this will be, then just return root. Okay, if L search, return L search. If you don't need the R search, just return R search. This will take care of the case where you didn't find the node also, because in that case R search will be null. Okay, so that's where we are now. This is where we have to take the case, right? So what we can do is if ANC not equal to P or ANC not equal to ancestor, okay, not equal to Q, then ideally your answer is fine. That means you found a common ancestor that cannot be found without having P and Q. Okay, so this is one case. The second case is if P equal to or the ANC equal to P, okay, then what we will have to do is we will have to do an underscore DFS ANC comma P. Okay, and what we can do is if this DFS returns true, that is it is able to find, sorry, not P, Q. So this is P, so we'll just check whether Q is available in its subtree. Check if Q is in subtree. Okay, so if it is there, then this means that we can return the answer, sorry, ancestor. If not, it is null pointer, because then that means Q is not in the tree. Now the other case is this is equal to Q. Okay, this, okay, let's just put it here, then I'll go back. So then that means this is P, and if P is in the subtree, then send the ancestor, if not null pointer. This will also cover P and Q is not null, is not present in tree. Okay, so this should cover all the use cases. Now let's write the DFS also. Bool underscore DFS tree node star root tree node star search, whatever we want to search actually. If root equal to null PTR, done, false. If root equal to S, return true. Okay, if then what we can do is return, so either it will be on its left subtree or we can check its left or right subtree. Wherever it is there, then it's good. Yes, so this should cover all the use cases. Hey, here we could just make this much more simple. Okay, we don't need to put another if else, so we can comment this out. Okay, and by default, if neither of these cases, then just return NC. Okay, I believe this is clear. So the special handling is this, where the ancestor is equal to P or ancestor is equal to Q. That's a special handling that we will have to do. Now let's try running this. Okay. Okay, so this looks good. Thank you. Have a good one.